Hi, and welcome to today's video. Thank you for joining me today. Today we're going to talk about solving inequalities. So if you recall, yesterday we talked about solving equalities. Today it's going to be just a little bit different. We're going to be solving inequalities. So now instead of having possibly one solution, we're going to have many solutions for our inequalities. So just a quick reminder, the solutions of an equation or inequality are the numbers that make the equation or inequality true. So in an inequality, what you're going to see is we're going to have a range of answers instead of just a single answer. We do use the same rules for inequalities that we use to manipulate equations, except the following. So this is important. Be sure to take this in your notes. When you multiply or divide by a negative number, you must reverse the inequality symbol. So we will have an example of that in just a second. But remember, multiply or divide by a negative number, that inequality symbol is either going to go from less than to greater than or from greater than to less than, either way. Solutions are graphed on a number line. So instead of just having a point, we're going to have an entire region of answers. So for example, in the inequality x is greater than 1, we have a little dot over here over positive 1, and our answer, our solution, is going off to the right. Okay, so reminder, when we are graphing strictly greater than or less than, we use an open dot. And so we have an open dot going to either the right or an open dot going to the left. When graphing greater than or equal to or less than or equal to, we use a closed dot. So closed dot going to the right or closed dot going to the left, depending on greater than or less than. So our first example, solve each equality and graph the solutions. So in A, we have 2x minus 5 is less than 3. So remember to copy the problem. So we've done that here. And now we solve it just like what we would do if this were an equal sign in here, except for now it's a less than sign. So remember, think order of operations backwards like we talked about before. So since we have minus 5, the first thing we're going to do is add 5 to each side of the equation. So 3 plus 5 gives us 8 over here. 2x minus 5 plus 5 gives us just 2x. So 2x is less than 8. So now, since we have 2 times x, we need to do the opposite and divide, the inverse operation. So 2 divided by 2 is 1, or just 1x here. 8 divided by 2 is 4. Okay, and now to graph our solution. So I have an open dot here above the 4, and since it's less than, it's going off to the left. So to check that, we just find a number in the solution area. So an easy one to always use if you can. You can't always use it, but if you can, try to use 0 because it's really easy to do calculations with the 0. So if I put 0 back into our equation, 2 times 0 minus 5 is less than 3. Well, let's see, 2 times 0 is 0, minus 5 is negative 5, and negative 5 is less than 3, so it does check out. Okay, for B, 2x, or 2 times the quantity x plus 1 is greater than or equal to 3. So the first thing we have to do here is use that distributive property. So we're going to just work with the properties and simplify the expression on the left, and then we will solve. So using distributive property, we have 2x minus 2, or sorry, negative 2x minus 2 is greater than or equal to 3. So if we do the inverse operation, add 2 to both sides, we get negative 2x is greater than or equal to 5. And now when we divide by a negative 2, remember we just talked about that, when we're dividing by a negative, the inequality symbol has to go the other direction. So instead of being greater than or equal to, we have to change it to less than or equal to here. So x is less than or equal to negative 5 halves. So remember, change that sign when we're dividing by a negative number. Okay, and now we have to graph our solution. So we have our number line. Negative 5 halves, well, that's negative 2.5. So if I go between negative 2 and negative 3 here, I'm about halfway. I use the closed dot because it's equal, and since it's less than, I'm going off to the left. Okay, so let's find a number to use to check in our solution. Now this time, 0 is not in our solution set, so we can't really use 0. So let's try, well, negative 3 is a number we can use. So negative 2 times the quantity, negative 3 plus 1, is greater than or equal to 3. So let's see if that works. Well, if we simplify inside the parentheses, negative 2 plus 1, or sorry, negative 3 plus 1 is negative 2. Negative 2 divided by negative 2 is positive 4, and 4 is greater than 3, so our solution does work for the problem. Okay, next example. Here in these two examples, you're going to see a case where we have either all real numbers or no solution. So first, solve the inequality and graph the solution. So here is the problem. 3 times the quantity x minus 1 is greater than 3x minus 5. So copy the problem. And of course, the first thing we have to do is use the distributive property again. So 3 times x is 3x. 3 times negative 1 is negative 3. So we have 3x minus 3. Okay. So now let's go ahead and subtract 3x from both sides. And notice what happens when we do that. There's no variable anymore. The variable is gone. So all we have left is negative 3 is greater than negative 5. So if we think about that, remember, since they're both negative, we want to look for the one that's farther to the right, and negative 3 is bigger than negative 5. So that is a true equation. So since negative 3 is greater than negative 5 is always true, the solution is all real numbers. And so to graph that, you just need a number line and then have a line above it with arrows going both directions because we want to include every number. So we're including every number by doing that. Okay, in B, 5x plus 1 is less than 5x minus 1. So again, if we subtract 5x from both sides, we get 1 is less than negative 1. Well, that is never true. So since that is not a true statement, there is no solution in this case. So always be aware, look for those. If the variables go away, we're either going to have a situation where we have all real numbers or no solution. Okay, next, let's do a little vocabulary. A compound inequality is a pair of inequalities joined by and or. So a couple things to note here. The solution to an and inequality must be true for both inequalities. So that's really important. If it's an and, our solutions have to work for both. If it's an or inequality, it only needs to be true for one of the two inequalities. So if it's true for one but not the other, that's okay. It only needs to be true for one of the two inequalities. And so we'll see an example of that here. Okay, so solve each compound inequality and graph the solutions. So here we are in A. 2x plus 5 is greater than or equal to negative 3, and 3x minus 4 is less than 8. So remember, our solutions have to include or work for both of these particular inequalities. So first thing, copy the problems, of course. 2x plus 5 is greater than or equal to negative 3. So we solve it just like we normally would. So subtract 5 from both sides. So 2x plus 5 minus 5 is just 2x. Negative 3 minus 5 is negative 8. And now divide both sides by 2. And when you do, you get x is greater than or equal to negative 4 on this side. Okay, solving the other one. 3x minus 4 is less than 8. So take care of the minus 4. Add 4 to both sides. And when you do, you get 3x is less than 12. So dividing both sides by 3, we get x is less than 4. So quick thing to note here, x greater than or equal to -4 can be rewritten if we just take everything and flip it around. We can rewrite that as -4 is less than or equal to x. So when we are rewriting our answer, we can put it as one single compound inequality. So -4 is less than or equal to x is less than 4. We would normally read that as x is greater than -4 and x is less than +4. Okay, so to graph our solution, we have our number line. Remember, we need a closed dot because we have equal to here, and an open dot because it's strictly less than here, and then connect the two. So our solution is all of these numbers in between -4 and 4, and of course we're including -4 because it's a closed dot. So again, let's check our answer. If we can, let's look for an easy number to use. How about 0 again? So if we take 0, 2 times 0 is 0, plus 5 is greater than or equal to -3. Well, since 5 is greater than -3, that is true. And let's try it for the other. 3 times 0 minus 4 is less than 8. Well, -4 is less than 8, so that is also a true statement. So 0 is definitely in our solution, and so it looks like where we have graphed is correct. Okay, next example. Here we have a slightly different situation. This is still a compound inequality with and. It's just written a little different. Notice 3x plus 7 is a part of two different problems. So we're going to go ahead and do this an easier way. We're just going to solve it as one complete inequality. So let's take a look in the middle. We want to get x all by itself in the middle. So to do that, we can subtract 7. And when we do, just like with an equation or inequality with two sides, we have to subtract it from both sides. Well, here we have to subtract 7 from all three parts. So when we do that, -18 is less than 3x is less than or equal to 15. And now to get x by itself, just divide by 3. So we have to do that to all three parts. So divide by 3 here, here, and here. And so when we do that, -18 divided by 3 is -6, is less than x, and is less than or equal to 15 divided by 3, which is 5. So here is our solution. Notice we don't have to rewrite it this time because it's already in that form. And we can graph. So again, open dot over this side because it's strictly less than, but here it's less than or equal to, so we do need a closed dot over the 5 and connect them with a line. And again, since 0 is in our solution, we can go ahead and pick 0 to check. If we put in here -11 is less than 3 times 0 plus 7 is less than or equal to 22. So if we just calculate in the middle, we get 7, and 7 is a number between -11 and 22, so it does work for our solution. So we have graphed the correct area here. Okay, one more like this. So we have 6x plus 2 is less than or equal to 8, or -2 times the quantity x plus 3 is less than -10. So again, copy the problem, and this time, once again, we're going to solve both sides of the both equations here. So solving this one, if we subtract 2 from both sides, we get 6x is less than or equal to 6, and then divide both sides by that, 6, and we get x is less than or equal to 1. On the other side, we do have to use the distributive property and simplify a little bit first. So when we distribute the -2, -2x minus 6 is less than 10. Sorry, -10. So add 6 to both sides. We get -2x is less than -4. Dividing both sides by -2. Now remember, since we're dividing by a negative again, we have to switch the sign. So instead of being less than, it becomes greater than. And -4 divided by -2 is +2. So our solution is x is less than or equal to 1 or x is greater than 2. So remember, it can be in either of these two regions to be part of our solution. So when we graph that, close dot over +1 with our arrow going to the left, and open dot over 2 going to the right. So this time we're going to check our answer a little bit differently. Instead of finding a number that is in the region for both, we can just do one check, or use one number to check, and let's pick one that's in between here. And it should not work for either equation. So we want both of our inequalities to end up being false when we check. So in between 1 and 2 is 1.5, or 3 halves. So if I put in 3 halves here, 6 times 3 halves is 9, plus 2 is less than or equal to 8. So we want to check that. Is that true or not? Well, 9 plus 2 is 11. 11 is less than or equal to 8. Well, that is false, which is what we wanted to happen. So that's okay that it's false, and we're good so far. When we put 3 halves into the other equation, -2 times the quantity, 3 halves plus 3, is less than -10. So we're going to simplify that. 3 halves plus 3. Well, 3 is with the same denominator of 2 as 6 over 2. Hopefully you noticed that. So 3 halves plus 6 halves is 9 halves. So -2 times 9 halves is -9. And so -9 is less than -10. Well, that is not true because -9 is farther to the right of the number line than -10. So that inequality is also false. And again, that's okay. That's what we wanted to have happen. So we're good to go there. So that is all I have for you today. I'm glad you joined me, and I hope to see you again soon.